Hello, everyone. How's it going? Hope all is well. Just want to make sure before I get started, I want to make sure you guys can see me well on the camera. You guys can hear me well. The microphone is good. Just making sure. Awesome, awesome, awesome. Thank you so much, everyone. All right, so today is the second of four sessions that I have prepared for my amazing students. So right now we have 42 attendees. That's wonderful. Just give me 1 second. I'm gonna make myself here. Okay, I'm just make myself a spotlight. So I'm gonna take a quick look. Okay, thank you so much, Mariam and Cameron and Nadine and Nireen, Reem, Khadija, I am doing great. Thanks for asking. Quick announcements. Let me share my screen. So I have two quick announcements. The first of which is that we have amazing assistants here with us. We have two assistants. So we have Miss Jenna and Miss Minna. Both are amazing. Miss Minna will take care of the chat box. As you can see, this is the chat box. And then Miss Jenna will take care of the Q&A box. So if you want to ask either of them any questions, please let them know, post your question, and they will answer you right away. Just want to let you know, both of them, Jenna and Minna, were my students before they graduated my course. They were high achievers. They got really amazing grades, really amazing scores. So you are in good hands. So let's get started. Where is my screen? All right, here is Zoom. Share screen. All right, so today's session, we're going to talk about the effect of volume and temperature on pressure. Have you ever heard of the term pressure before? I want to make sure. Can you guys see my screen? No, not yet. Hello, Doha. Do you guys see my screen yet? Yes, no, not yet. Okay. No, yeah. I do not see it either. So where is it? Oh, you can see it? Not yet. Okay, some people said no. Yeah, I don't see it either. Yeah, 1 second. View, gallery maybe. Okay. Speaker. Yeah, I cannot see it. 1 second. Let me try again. What is wrong with Zoom today? You see the screen? Because everybody else said no. They don't see the screen. Yeah, Cameron said no. Khadija said no. Huh. I wonder what's going on. Let me try again. What I'm gonna do is I am going to leave the Zoom and come back again, and maybe that's gonna fix it. Maybe. Yeah. Okay, let's actually try again. Yes, it should work. Nireen, she says hopefully it works. It should screen broadcast start. Okay, 3, 2, 1. Is it working? No. Oh, it is. Yay! I think it is. Awesome, awesome. Thank you for your patience. All right, so what we will talk about today is the effect of volume and temperature on pressure. So pressure is a term that you start hearing in your school during your early studies of science and chemistry. So before I get started, this is the second session. So I hope that you all saw. Now I recognize many names here. So I know that you were here last week, but there was a session number 1 and it's on YouTube. I posted it on YouTube. You can go to my channel. You can scan this QR code. You can go to this link. I hate typing links. So you are new here, Khadija. So no problem. You will understand. You will be able to understand today's concepts. But I really encourage you after this live session to go back to the recording. Okay, Khadija? All right, so that was last week's session. A quick reminder that my book is free today on Amazon, the digital copy though, not the hard copy. The hard copy is also cheap. I think it's like $7 or something. Um So go to Amazon, scan this scan this QR code, and the book is going to be free today. Okay. So Amazon allows authors to make the book free. Uh, Notes for a few months ago, my mom showed me you, Miss, and but to me your topicals. Yeah, yeah, Yusuf, that's amazing. That's really great. So start studying from them. And do you have my notes? I hope you do. So, Doha, it is available in hard copy. No, the digital form is free. So the digital, I don't know if it's a PDF or what. I don't know what Zoom does. Amazon, I mean. So yes, it is free today, Doha, but just today. Okay, so make sure you go and download it today. Okay. All right, so last session we talked about the three states of matter. We talked about solid, liquid, and gases. And if you remember, I hope you do, we also talked about how you draw the structure if the examiner asks you to draw the structure. We also talked about how they are separated from each other and what are the key words that you have to write on the exam. We also talked about arrangement. Are they regularly arranged or are they randomly arranged? We also talked about motion and how they move. And how's that related to people? How is motion of particles related to people? So, for example, solids are similar to what? Solids are similar to what? Solids are similar to adults. Thank you. Excellent. Very, very well. What about liquid? Liquid is similar to teenagers. Thank you, Sumaya. Thank you, Cameron, Ahmed, Mahmoud, Nireen. Thank you very much. And gases are similar to those teenagers that move and they're fast and they're all over the place, right? So we talked about motion, we talked about energy. Same thing, the energy of adults, I mean, solids are not very much. They're just fixed, they're just vibrating very low energy. And then teenagers have a little bit of energy and they're walking around. And then toddlers, oh, those toddlers, they are running all over the place. They have a lot of energy. And then we talked about how this energy or what affects energy. What is the only thing that affects energy? Now, with toddlers, it's sugar, but with particles, it's. So, what affects the energy of particles? Not force, Jessica. No. Something else? Yes. It's temperature. You give it temperature, you increase the temperature, you heat it up, the energy increases. And that's going to be the topic of today. So you really have to know this part because we are going to talk about the effect of energy and the effect of pressure a lot. And I'm going to ask you a tricky question. Usually students don't get it, but like don't get it right. But then, so we'll see. This group is actually very smart. So we'll see. Okay. And we also talked about forces of attraction. And we said these are not bonds because bonds is something else that we will study later. Bonds is something that attaches atoms together. So this is very different. Forces is what keeps the particles close to each other. So in solid, there's strong force and the particles are very close to each other. In liquid, the forces are a little bit weaker. And then in gas, there's almost no force. There is a little bit of force, but it's so weak that particles are so far from each other. All right, so this slide is basically the summary of the last session. 1 hour of teaching summarized in one slide. Everything good? Everything clear? Do you have any questions? All right, looks like everyone is following. That's amazing. Now, the last thing that differentiates solid, liquid, and gas is compressibility. How can you compress something? Question. Solid. Can you compress solid? If you have a book, okay, or you have a laptop, which is totally solid, all solid, right? This is my daughter's laptop, all stickers and stuff. She's a teenager, by the way. Can you compress solid? Can you compress solid? Okay, I'm not gonna mess with my daughter's laptop. No, you cannot compress solid, right? So it's really hard to compress solid. And the reason is the particles are already very close to each other. Look at this. Look at the particles. Look at how close they are. You cannot make them get closer than that, right? Ahmed, not bonds. Ahmed, those are forces of attraction. I don't want to hear the word bonds again. Bonds is completely different topic. Okay, Ahmed? So I'm glad you said that. Okay, it's not bonds, it's forces of attraction. And I'm glad you made this mistake because we are learning, right, Ahmed? Okay. All right, what about liquid? Can you compress liquid? Skittle is Razan's sibling, Razan's brother. We actually have a lot of siblings here. Okay, so can we compress liquid? Some people said yes, and some people said no. Oh, you are Ian? Okay, that's amazing. So Skittle is Ian. All right. I'm gonna try to memorize that. So can you compress liquid? So some people said yes because there's a little bit of space between particles. Reality is it's hardly compressible. Hardly compressible. You know why? Because the particles in the liquid are very, very close to each other. So it's really hard to compress liquid. So I'm going to say no, even though there's a little bit of space, but it's hardly any space. And most particles are actually touching each other. Yes, they can move, but the spaces between them is hardly any. Okay, so we're going to say no, we cannot compress liquid. All right. Lastly, gas. Can we compress gas? Can you compress gas? Yes, you can. Yes, you can. Because look at this. Look at this. The particles are so far from each other. So can you compress them? Can you join them? Can you make them closer? Can you make them closer to each other? Yes, it is easily compressible. Now, how is this helpful? How is the fact that you can compress gas? How is this helpful? What do you think? How is it helpful that you can compress gases or gas particles? It's actually very helpful. But why? Okay, someone said more pressure. And why is that helpful? Raghat said high pressure. Okay, a lot of people said higher pressure. Correct. But why is that helpful? Why is it helpful to bring a big gas and compress it in a small volume, into a small container where you can transport it from place to place, right? So I have a question for you. I have a question for you. If, for example, you are a doctor, many of you last time said you guys want to be a doctor, right? And when you're a doctor, you work in hospitals and you are going to need gas syringes or oxygen cylinders because your sick patients will need oxygens. Okay, so 5 years ago, you guys remember COVID, right? You guys remember COVID when people got really, really sick and they were unable to breathe and they had to go to the hospital and yeah, okay, you guys remember COVID. You guys were in elementary school probably, right? Okay. So people had to go to hospitals and they had to be on oxygen. Basically, they had to put the mask on. And so we had to provide oxygen in hospitals. Question: if you were a doctor or if you work in a hospital, would you rather provide these oxygen cylinders at regular volumes where oxygen particles are so far from each other and oxygen takes huge volumes and you're going to need to store these gas syringes, these oxygen syringes in large rooms, in large volumes, or would you rather squish them, squeeze them, compress them into small volumes, small containers, so you can have space? Yeah, Reem, she's like, yeah, that makes sense, right? So that's why it is super helpful to compress gases into small volumes. Example is oxygen for hospitals, oxygen cylinders for hospitals. Those oxygen cylinders are actually not at regular volume. They are squished and squeezed and compressed in a small volume so that we can afford storing them. Otherwise, it's going to be so expensive to store oxygen. You're going to need buildings upon buildings upon buildings to store oxygen, right? But fortunately, we can squeeze or we can compress oxygen into a small volume. So one example I just said is oxygen. You know, we can use it for hospitals. Where is oxygen needed else? Where do we need oxygen? Where else, other than hospitals, where else do we need oxygens? Underwater. Divers, exactly. Divers who go underwater need oxygen tanks or oxygen cylinders. Judy says everywhere. Astronauts. Thank you. Was that Sumaya? Thank you. And Maryam also said astronauts. Thank you. That is an example because when astronauts go to space, they are going to need oxygen cylinders and they're not going to take oxygen at regular volume, right? Otherwise, the spaceship is not going to fit all the oxygen. So we squish them, we compress them into small volume. All right. What else is compressed into small volume other than oxygen? Other than oxygen. So we said hospitals, we said divers, we said astronauts. Astronauts. All right. What else? What else? Nitrogen is compressed under, yes, small volume. Something you may store in your kitchen, or I personally store in my kitchen, and I have a couple in my house. I have one in my garage, I have one in my kitchen in case there's a fire. Fire, thank you, Cameron. Exactly. Fire extinguishers. And what does fire extinguisher contain? What gas? Excellent, Minna. What gas is in fire extinguishers? What do they contain? Under it compressed in a small volume. Compressed in a small volume. Thank you, Iyad. That's right. Thank you, Cameron. Not carbon monoxide, it's carbon dioxide, and the formula is CO2. We're gonna learn about formulas. Do not worry. This is a whole lesson. So do not, some people said CO and the formula is CO2, but that's fine. Thank you, Nireen. Thank you, Yassine. Thank you, Muaz. Thank you, Awesome, Reem, Mariam. That's amazing. Amazing responses. So you guys did mention that when we compress a gas into a small volume, you guys mentioned it, several of you mentioned it, we have a scientific name. We say this gas is under high what? High what? Excellent. Thank you, Gina. What is the scientific name? Wonderful. Oh, look at you. You guys are so smart. That's right. We say it is under high pressure. We say it's under high pressure. So that's the scientific name for squishing. On exams, you don't say squishing a gas. You don't say compressing gas. You say it's under high pressure, meaning those particles, same number of particles, are squished or squeezed or compressed into a small volume. All right. Now, I drew 3 particles in container A under normal pressure. I drew 3 particles in container B under high pressure. So I have the same gas, same amount of gas, same number of particles of gas, just in a smaller volume, and that's where we call it high pressure. Now, there is a famous exam question. Examiners usually, sometimes, not very much, it's not a very common question, they would ask why. Why does decreasing volume, sorry, this is the wrong one. Why does decreasing volume increases pressure? Why does decreasing volume, so I'm going to talk, so concentration is different, Kareem. Concentration, okay, Kareem has a really good question, guys. Kareem asked, what about concentration? So concentration is when you have a lot of particles in a small volume, but we use the word concentration for aqueous solutions, for liquids that dissolve. So your cup of tea, your soup that has salt in it, these are liquids that have salt dissolved in it, and we call it concentrated salt or concentrated solution or dilute solution. Very different concept, okay? Which we will talk a lot about in your course, all right? Okay, so when examiners ask, why does decreasing volume increase pressure? And I can tell that Miss Minna is very busy with questions and Miss Jenna is also very busy with questions. I love them both. Thank you very much. It's amazing. So yeah. So the question again, I'm going to repeat. How does decreasing volume increases pressure? Why did it matter? Why did the pressure increase when you... Okay, some people said they hit harder. Unfortunately, wrong. I'm going to tell you exactly what to write on the exam because it requires heat. No. Let's say this is at regular temperature, 25 degrees C. This is also at regular room temperature, 25 degrees C. Okay? Because they have a relationship between volume and pressure. Yes. Okay, so on exam, what you write on exam? The reason. Now, the word pressure, you're going to learn it from physics. Pressure just usually means pain, right? It's like boom, boom, boom. The particles are hitting each other and are hitting the wall very frequently. So in A, for example, particles, we know that particles are moving around. These are gas particles, right? These are like toddlers. They are like all over the place and they're hitting the wall, boom, 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 right? So this particle is hitting the wall, hitting the wall, hitting the wall, hitting the wall, and so on, right? What about B? Same thing. It is hitting the wall, boom, 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 and so on, right? Which one, container A or container B, booms or collides or bombards or hits the wall more frequently? Thank you, Cameron, Subaya, Reem, Muaz, Jessica. You guys are reading my mind. Why? Before I even finished the question, they answered. That is right. In B, the hitting of the wall is more frequent. So in A, it's like boom, and then boom, and then boom, and then boom. It's regular pressure, not too high. In B, it's like boom, 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 right? Why? Why is the hitting more frequently? Now, on exam, I like the word collide. Collide with the wall. I like the word collide. Now, if you say hit or bombard, that's fine. That's fine, okay? But I like the word collide, okay? Yes, Kosai. Hello, Kosai. I saw your message. I think I saw you texting me on WhatsApp, but I didn't get it. I'm so sorry. So yeah, in B, the collision is more frequent with the walls. Why is the collision more frequently with the walls? So this question comes in exam worth 2 points. It's worth 2 points. The second point is you're going to say, therefore, the particles collide more frequently with the inner wall. What is the first point? Why are they colliding more frequently with the wall? Mark, that's correct. Cameron, correct. More pressure? No, that's not enough. Okay, we know it's more pressure. Muaz, almost there. Muaz said, because the container is smaller. So what? So what? Aha. Okay, Asim, Adam, Kareem, Sama. Exact, Sama. Perfect, Sama. This keyword is perfect. You're going to say that the particles are now closer to each other. Closer to each other. Okay? Doha, yes, I will repeat. I think, Doha, you are Dua's sister, right? Okay. All right, so you're going to say that particles are closer to each other and therefore they collide more frequently with each other and with the inner wall. Okay? Easy? All right, I'm going to repeat. I'm going to repeat very quickly. If the examiner asks you, why does decreasing the volume increase the pressure? You're going to say, in B, for example, when the volume is decreased, you're going to say volume decrease. So you're going to say here, volume of the container decrease, and therefore particles get closer to each other, and therefore they hit more frequently. I like the word collide. They collide more frequently. Doha, do you understand now? They collide more frequently. Okay, do you understand now? 2 points. Here's the answer. Now I have a question. Is collision a word? Of course, Khadija. Collision means hit or bombard. Okay? All right. Thank you, Nireen. All right. So my next question for you is, can we say on the exam, because particles have more energy? Yes or no? And can we say on the exam, because particles hit harder, or with more force, or with more energy? Can any of these keywords work? Will you get a point for any of these? Okay, so the answer is you get a big fat 0 if you write any of these words. Not a chance, exactly, yes. You get a big fat 0 if you write more energy, they collide harder, they collide more with more energy, they collide with more force. None of that works. You know why? Because I just said that both here are at the same temperature. Same temperature. I did not say anything about temperature. Did I say anything about temperature? Did I say that B is hotter than A? I did not, right? The teacher Razan is saying to check her messages. Oh, Skittle. Oh, that's right. Okay, so if you say anything about energy, about particles more energetic, particles are more forceful, particles are hard, like hit harder, you get 0. Okay, so usually, Doha, this question is usually 2 marks. If it's 3 marks, you write this and you still get the 3, but I've never seen it worth 3 marks. It's usually 2 marks, okay? So, because I didn't say anything about temperature, I just said that I squished the volume. You're not allowed to say anything about temperature because I did not change the temperature, right? So it's all about more frequent collisions because the particles are closer to each other. Easy? Easy, everyone? Oh, Jenna is saying, please send your question once. She can see. Looks like Miss Jenna and Miss Minna are overwhelmed with questions. That's amazing. This is a really good group. You guys are asking questions, and that's amazing. Okay, but please put the question once. Okay. All right, Melek. The examiner said that I have container A. Okay, because Melek said she didn't understand. I'm repeating for Melek or anyone who didn't understand. Okay, I'm repeating. Oh, it's okay, Mariam. Mariam says sorry. It's okay. They see your questions. They are gonna answer it. Yeah. Sorry for spamming. It's okay. All right. Malak. Malak. Anyone else who needs me to repeat? Because I'm repeating for Malak and I'm repeating for everyone else. So continue to answer my questions. All right. Malak, examiner said that I have container A, big volume, and the only thing I changed is I did not change the temperature, Malak. Okay, the only thing I changed is I compressed the volume. I decreased the volume. Okay, Malak? So far, so good. So the particles became closer to each other. And therefore, when the particles got closer to each other, they started hitting more frequently. Instead of boom, 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 it's like boom, 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 boom. Do you get it now, Malak? Okay, Malak, I'm going to give you another example. Everyone, not just Malak, okay? Imagine if I have a daycare, okay, and I put, everyone focus, okay? And I put 5 kids, 1, 2, 3, 4, 5. I put 5 kids in a room, all right? And you guys know kids. These are toddlers. They are moving, they are colliding, they are boom, boom, boom. But the room is big. Do you think the boom, boom, boom is going to be very frequent? Like every once in a while, the teacher is going to get a kid who hits his head in the wall, right? Maybe 1 in an hour. You know, 1 kid hits his head per hour. Not very much, okay? And then all of a sudden, I just had to move the kids into another room. And I moved these 5 kids into a really small room, okay? These are how many kids? 1, 2, 3, 4, 5. Okay, so 1, 2, 3, 4, 5. Now, what do you think, Malak, is gonna happen now? Do you think you're gonna get a 1 hit per hour or like 6, 7 hits per hour? They're gonna be like boom, 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 right? So that's basically when particles are under high pressure. They hit the wall more frequently. Do you get it now, Malak? Now, for exam purposes, do you understand it now, right? Okay, for exam purposes, the keywords you need to write is the particles get closer to each other, and therefore they boom. Instead of boom, you're gonna say collide, and therefore they collide more frequently with the wall. Okay? Easy, everyone? So these are the keywords. But Malak, I did not say anything about energy. I did not say anything about temperature. So if you write anything about temperature, anything about energy, you don't get a point, right? Okay, everyone gets it? All right. Next question or next scenario. I kept the volume the same. I put the kids in the same size room, big room, okay? But this time, the first room is cold at 25 degrees C. The second room, ooh, it's hot. I heated it to 85 degrees C. Yes, there will be Kahoot, Reem. Yes, I've prepared the Kahoot for you. I think there's 12 or 15 questions. But I made it harder this time, so you better focus. Okay. Raghat says, yes, thank you very much. It's like putting kids, you know, you have these kids in a room. They are in the same room, but this time what I did is I fed them sugar. What are they going to do? What are particles going to do? Ooh, they're going to move faster, right? So instead of moving really slow, really slow, really slow, and every once in a while there's a boom, right? In B, it's like boom, boom, boom. They are moving faster. They are moving way faster. So, what do you think about the frequency of collisions? What do you think about the frequency of collisions? Faster in A or B? Faster in A or B? Yes, room B will have faster collisions, more frequent collisions. Now, when we have more frequent collisions, we say that B has higher energy and therefore higher, because of higher collisions, we say higher. Yes, Yassine. Higher, Yassine, energy and therefore, Mariam, yes. Pressure, thank you, Minna. Higher pressure. Wonderful, thank you, Judy. Okay, so if the examiner says, why does increasing temperature increases pressure? Usually 3 points, 3 marks. What are the keywords? What's the first thing you're going to say to get the first mark? Thank you, Sumaya. That's right. That is the answer. Something about energy. Excellent, Jessica. Excellent, Jessica. Thank you, Raghad. That's right. And Najah, yes, you say more collisions. That's the second point. So the first point is you say that particles gain energy. And therefore they, second mark, collide more frequently is the third mark. And therefore they move faster, right? They move faster. That's the second point. Usually students forget this one. Did you guys forget this one? Yeah? Many of you forget this one. This one is the second mark. If you have 3 marks, this is the second mark. Yeah, Khadija, thank you. All right, and then the third mark is, therefore, they collide more frequently with the wall. And that's why pressure increases. Okay, did everyone understand? That's the third mark. Everyone understood. Wonderful. So now I'm going to ask you 2 questions. Awesome, Ali, thank you. I'm going to ask you 2 questions to make sure that you guys all understood. And these 2 questions has to do with the relationship between pressure and volume, and the relationship between pressure and temperature. Let's start with the relationship between pressure and volume. When you decrease volume, when you compress the gas, you decrease the volume. What happens to pressure? Doha. Thank you, Muhammad. Thank you, Sumaya. Thank you, Yazan. Yazan. Is it Yazan, right? Yeah. When you decrease volume, pressure increase, right? Because when you decrease volume, particles get closer, they collide more frequently, so pressure increase. Now, in math, when you have opposite relationship, you say they are, when you have opposite relationship, you say exactly, thank you very much, you say they are inversely proportional. And this is in the Kahoot, okay? Wink, wink. All right, they are inversely proportional. All right, what about this? What is the relationship between pressure and temperature? When you increase temperature, particles get energetic, they move faster, they collide more frequently, and therefore pressure also increases. And so they're going in the same direction. As temperature increase, pressure increase, and therefore they are, look at you guys, so smart. Thank you very much. That is right. They are directly proportional. They are directly proportional. That's amazing. All right, so with that, I am actually done, but I have some example questions for you. I have some examples for you. What is an application, a real life application, something you see at home, something you see in your kitchen? What is a real life application of increasing temperature and therefore increasing pressure? Something in your kitchen. Yes, cooking. Thank you very much, cooking. So have you guys heard of the pressure cooker? Pressure cooker? Why is it called pressure cooker? Why? Because the volume, okay, so basically here's your pressure cooker. All right, and here's your food, here's your vegetables, your meat, your soup, your salt, everything, right? And of course, there's a lot of water here. And then what happens to water? Water evaporates, right? And it gives you gas particles, like there's water vapor everywhere, and this is gas, so this is like the toddlers who are moving fast and they're hitting the thing. What we do in pressure cooker is we close it very tightly. We close it very tightly, so it's tightly closed so that gas is not allowed to leave. And so the gas is hitting and bombarding and, you know, colliding inside, and they're not allowed to leave. So what happens when you increase temperature? You're putting this on your stove and you are increasing temperature. You're giving heat right here. Right? What's going to happen? What's going to happen to the gas particles? Of course, liquid particles will move faster. But what will happen with gas particles? Excellent, Zaina. Excellent. Wonderful. So the gas particles here will gain energy because you increase temperature. Okay, the only thing that causes energy to change is temperature. And therefore, so that's the first point, and therefore particles move faster, and therefore particles collide more frequently, and therefore pressure increase. Now, how is increasing pressure a good thing? How is increasing pressure a good thing? Actually, why do moms love pressure cooker? Oh, I should buy one. I don't think I have one, but why do moms like Yeah, exactly, Yassine. Exactly, Ahmed. Exactly, everyone. Thank you very much. The cooking happens faster. Instead of cooking in like 1 hour, it finishes in 30 minutes. Boom, I'm done. I'm happy, right? So, I have a question for you. When you're done cooking, do you open? Okay, this is a hand. Oh my God, that's a horrible hand. Four fingers, 1, 2, 3, 4. Okay. When you're done cooking, do you open right away? Do you open the lid right away? No, you guys are right. You do not open the lid right away. Why not? Why not? So remember, this gas is under high pressure. It's squished, it's squeezed, it's compressed. So if you open the lid, what are particles gonna do? They're gonna move quickly and go out quickly, right? And they're gonna burn your hands because this is gas under high pressure. So tip for you, anybody of you who likes cooking, here's a tip. If you're using a pressure cooker, if you're done, first switch off the heat, let it cool down all the way so that the pressure goes all the way down, and then open the lid. Okay, Nadine says I don't understand this part. So Nadine, when let's take the examples of the kids, okay? So these kids are under high pressure. They're moving fast and they are energetic and all over the place, Nadine. What do you think happens if you open the door suddenly? What do you think happens if you open the door suddenly? While these kids are all, they will escape fast, right? They will move fast. You will trip, right? So that's exactly what happens with the pressure cooker. If you open the lid while the gas is still energetic, the gas will escape very fast and it will burn your hand. Do you get it now, Nadine? Mariam is asking, is this question related to diffusion? No, however, diffusion will occur once you open the lid. Once you open the lid, this vapor will go out and it will start diffusing all over your house. So yes, we will study about diffusion later, okay? All right, another pressure question. You have this balloon, and you started blowing air into it. You're like, you started blowing air into the balloon. What's going to happen? You're putting more particles, right? More and more and more particles. Why does the balloon eventually burst? Now, this question is not on exams. I've never seen it on exams. I just want you to think, because there is in space, okay, kind of. But there's another word. If you want to talk scientifically, exactly, Reem, thank you. Adam, thank you. Gas particles are trapped. There's another scientific word. Huda, thank you. Hamad, yes. Yassine, yes. Okay, so you're going to talk about in terms of pressure. What do you think about particles in A? They are colliding, right? They are hitting the wall. So here's, oopsie, here's the particle hitting this wall, hitting this wall, hitting this wall, hitting this wall, just randomly. So there's boom, boom, boom. What about B? What about B? There's so many more particles, and they are like boom, 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 boom. And therefore, the pressure is so much higher. And if the pressure is so much higher, eventually the balloon will burst. Okay, so if you were to talk scientifically, keywords, you're going to say we've added more particles in a limited space, and therefore these particles will collide more frequently with the inner wall and eventually burst. Question: can I say within my answer that particles in B have more energy? Can I say that, and will you get the mark? You guys are smart. I love you. That is right. You're going to get the big fat zero. There's no more energy. It's not more energetic. Why not? Because I did not say anything about temperature. I did not say anything about temperature. I did not say anything about temperature. Say, for example, this is 25 degrees C. This is also 25 degrees. I did not heat the thing. The only thing that affects energy is increasing temperature, or decreasing temperature, of course, decreases energy. Easy? All right. One more question. And this actually is a hard one. Very challenging one. Students usually don't get it like at first. Okay. You know, I live in a very cold place. Temperatures are sometimes, let me show you my the temperature here. Sometimes it's like what? Okay, right now it's -14, feels like -14, but it's actually -8. Sometimes it's like -20, -30, very, very cold. So if in the cold weather, what do you think is gonna happen in the cold weather? What's gonna happen to the air inside your tire in the cold weather? In the cold weather. Yeah, Khadija, same thing in London, exactly. Very, very cold. But I don't think it's as cold as me, as Laramie, Wyoming. I don't think so. But anyhow, what temperature is it? So temperature drops. If the temperature decreases, becomes really cold, what's going to happen to the air inside the tire? They are going to, will it burst? Will it burst? Uh-huh. Adam, almost there. Yeah, less cool. Exactly, Najee. That's right. So at lower temperature, do particles have more energy or less energy? More energy or less energy? Way less energy. Less energy. So if they have less energy, are they moving faster or slower, Adam? Excellent, Judy. Thank you, Mazen. Thank you. Doha, thank you. They move slower. They move slower. Way slower, right? They're like lazy. Ugh. And if they move slower, are they going to collide more frequently or collide less frequently? Yeah, they collide less frequently, right? And if they collide less frequently, what happens to pressure? What happens to pressure? Excellent. Thank you, Doha. Thank you, Huda. Thank you, Abdullah. Mazen, Abdullah, Abdurrahman, sorry. Dana. Pressure decreases. Pressure decreases. Do you want to drive a car with low pressure in the tire? No, you want good pressure in your tire. Otherwise, it's not going to drive well. It's going to be flopping. Like it's going to be flop, flop, flop. Like, have you guys had this event before? I've had it before where I had a flat tire and it was not inflated enough. And it was like, I was driving and it was like, blop, 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 blop. Like, it was like not driving well. And I had to stop by a gas station and fill it with air. Okay. So Mariam, I'm going to repeat again. In the cold weather. Now, Mariam, do you like cars? Do you like cars? So, Mariam, basically, your tire in your car or your bicycle. Okay, you like cars. Wonderful. I like to bike to work. I bike to work. So, my tire in the bicycle, it has to be inflated. It has to be full of air. It has to be under high pressure so that it's fat. And when it's fat, it drives better. Right, Mariam? Now, sometimes we have this issue. In very, very, very cold temperature, the air inside your tire will become lazy and they're gonna be like, ugh, and they're gonna be colliding very less frequently, and so the pressure decreases. And when the pressure decreases, you're gonna feel it in your tire. It's gonna be like not fat enough. Do you get it now, Mariam? Yeah, she's like, oh, she gets it now. Wonderful. Okay, so keywords here, you're gonna say number one, particles lose kinetic energy. And by the way, this is not an exam question. I just created it based on real life events, stuff that we face every single day. And when they lose kinetic energy, they move slower and lazier. Oh, and then therefore they collide less frequently and therefore pressure decreases. Okay, all right. Question. Based on today's session, we're almost done. We're almost done. Based on today's session, what are 3 ways to increase pressure? 3 ways to increase pressure. 3 ways to increase pressure. Excellent. Okay, so the first way, I think most of you wrote increase temperature. Increase temperature. That's right. And what is a real life application? Something you see in your home, in your kitchen. Cooking, the pressure, to be specific, the pressure cooker. Exactly. That is an example where you increase temperature, you increase pressure, you cook faster, mom is happier. All right. Mark, do not say force. Say collision, increased frequency of collision. Okay, because you have to be very specific, Mark, in your exam. Okay. All right. Second way to increase pressure. Second way to increase pressure. Decrease volume, squish it, compress it, right? Decrease volume is the second one. And what is a real life application of this? A real life application of decreasing volume and therefore increasing pressure. Tanks, oxygen tanks, fire extinguishers, pushing a syringe. Yes, Mariam Amr, that's right. Thank you, Abdullah. Thank you, Lean. Thank you, Adam. Thank you, Mariam. Thank you, Save. You guys are amazing. Third way to increase pressure. Third way to increase pressure. Excellent, Sumaya. Oh, you said force because force equals pressure equals force divided by. Oh, that's okay. So Mark, what you're talking about, pressure equals force divided by area. That's when you have a force on a solid or a liquid, okay, not a gas. And yes, you do study this in physics. That is correct, okay. But here in chemistry, I want you to talk about increased pressure for a gas, okay, Mark? Yes, I mean, I loved physics, so yes. I love this equation too. All right, third way to increase pressure. Increase particles. Thank you, Awesome. Collisions. Increase amount of air. Thank you, Dana. Minna. Thank you. Thank you. Yes. And you guys are right. You add more particles. You blow a balloon. You add more particles. And a real life example is the tire. Increasing the particles. Increasing air particles in a tire or blowing a balloon. Easy, everyone? All good? Okay, now I am done with today's lesson. However, there's a concept that I want you to master and be really good at. And the reason is we're going to study it. We're going to need it a lot next year. And basically, it's a math concept. It's called cross multiplication. Mahmoud, what did you not understand? This slide? So there are three ways to increase pressure. What is the meaning of increased pressure? Collisions, more collisions. Boom, boom, boom. Okay, Mahmoud? All right. So math concepts that you will use in chemistry, something called, I don't think you understood, Mahmoud. Be specific. What is it that you did not understand? Just want to let you know Miss Minna is here. Miss Jana is in the Q&A. She answered so far 54 questions. That's wow. These two assistants are my favorite. The last part, this part, if you add more particles, this is balloon A, this is balloon B. Which one has higher pressure? Mahmoud, which one has higher pressure? Balloon B, that's right. Why? Because there's more boom, 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 right? There's more collisions. It's going to collide with the wall more frequently. All right, do you get it now, Mahmoud? Mahmoud? Just want to make sure. Okay, you got it? Wonderful. All right. Okay, so this math concept is something called cross multiplication. Do you guys all know how to use cross multiplication? Please say yes or say no. Okay, a lot of people said yes. One person said no. Just one person said no. Two people said no. Three people said no. Not bad. Among 103, only 3 said no. Wonderful. That's really good. Okay, let's say, okay, let me ask you a question. How many slices of pizza can you eat in one sitting? How many slices of pizza can you eat in one sitting? Lean says 2. Mariam said 3. Nadine said 3. Cameron said 6. Some people said 8. Oh my God. So Yazan said 10. My goodness. Okay, I can do 2 and sometimes I can do 3 if I'm too hungry. Okay. All right. Let's say a typical friend, your typical friend eats 2. Okay. And so you know that if you invite one friend to your house, this friend will eat 2 slices. All right. Let's say you're having a Khadija, I just started right now. I did not say a thing. Okay, Khadija. All right, focus. So Khadija, you know that if you invite one friend to your house, she's going to eat 2 slices. Let's say you're having a birthday party and you're going to invite 25 friends and you want to make sure you have enough food for them. How many slices of pizza are you going? Look at you guys. How many slices of pizza are you going to buy? Okay, so you know, that if you invite one friend, she's gonna eat 2 slices. If you're inviting 25 friends, how many slices should you buy? You guys are amazing. That's correct. It's gonna be X. And what is X? X is going to be 50. How did you get 50? How did you guys get 50? What you did is you multiplied 2 times 25, right? Yeah, that's called cross multiplication. That is called cross multiplication. X is these two numbers multiplied by each other. So 2 times 25 divided by the number opposite to the X. So divided by 1. Easy. The 3 people who said they don't know anything about cross multiplication, do you get it now? Do you get it now? Everyone. Excellent. Excellent. Thank you, Mark. Where is Khadija? You also said you don't know it. Okay, you guys all get it. Kinda? Okay, I'm going to give you another example, Khadija. Another example. And then we're going to do Kahoot. All right. Say, for example, if you want to make 1 cup of tea, you want to make 1 cup of tea. All right. And to make 1 cup of tea, Khadija, you need 2 teaspoonfuls of sugar. All right. You need 2 teaspoonfuls of sugar. Here's 1 and here's 2. All right. So to make 1 cup of tea, you need 2 teaspoonfuls of sugar. What do you mean, Iyad? I don't know what you're saying. I'm gonna have Minna answer you because I cannot. Okay, Mark says, yes, Mark, that's right. That's right. Okay, so let's see this example, Mark, and see if you get it. Also, Khadija, and who said kinda? Yeah, Khadija said kinda. Okay, so to make 1 cup of tea, you need 2 teaspoonfuls of sugar. What if you're making a party? Okay, and you are going to make 35 cups of tea. You're inviting people to your house and you are going to make 35 cups of tea. How many teaspoonfuls of sugar do you need to make sure it's in your house? Look at you guys. That's amazing. That's amazing. Khadija, do you get it now? Okay. Minatullah, no. Judy, yes. Okay, do you get it now? So this is X. This is the unknown. What is X? X is these 2 numbers multiplied by each other divided by the number that's opposite to X. So it is going to be the 2 green numbers, 2 multiplied by 35, divided by the number opposite to X, so divided by 1. And so this number is going to be 2 times 35, which is 70. Do you get it now? Mark, Khadija? So yeah, 35 cups. I didn't mean 3 cups. Do you get it now? All right, so basically in cross multiplication, you're going to have 2 statements. The first statement, the second statement, and then one of those 4 numbers is going to be an X. It's going to be an unknown. So just to give you a very quick recap on what should I divide by 1? If the opposite number is 1, you divide by 1. Yeah. So if you have, for example, okay, how about a complicated example? How about a complicated example? Okay, let's make it a bit harder, okay, to make sure that everyone gets it. Let's say that if you are making soup and you're making 300 milliliters of soup, 300 milliliters of soup, okay? Let's make it here. Okay. So if you're making 300 milliliters of soup, you need 10 grams of salt. All right, here's a cup of soup. Copy. Why should I divide by 1? Okay, so Malak, the number that's opposite to X is going to be in the denominator, Malak. Do you get it now? The number that's opposite to X is going to be in the denominator. So if it's 1, then you divide by 1. What if this number was 2? You divide by 2. Okay, so Malak, that's why I'm having a complicated example. Okay, but let's focus. So Malak, let's say if you are making this cup of soup, which is 300 ml of soup, you need 10 grams of salt. What if you are making 6,500 ml of soup? How much salt will you need? How much salt will you need? How much salt will you need? Is everyone here? Did they get kicked out? Oh, people are here. Okay, good. Mariam already calculated it. Good, Mariam. May, Mahmoud, that's correct. Mark, your number is a bit different. Iyad, your number is a bit different. Everybody got 217 or 216.7. So what is X? So here's X. Here's X. X is going to be these two numbers multiplied by each other. These two numbers multiplied by each other. So it's 10 times 6,500. Divided by what? Divided by the number opposite of X. So divided by 300. You guys get it now? Where is Malak? Malak, did you get it now? Khadija, did you get it now? Mark, I think you got it because you did the calculation. Okay, Malak said yes. Omar, Khadija said yes. Wonderful. Muhammad, Iyad. Look at you guys. M, you say you don't get it. So for cross multiplication, do you understand that sometimes we have an unknown, right? You have the paper next, okay? You have an unknown, this X. To calculate X, the two numbers opposite of the X, you multiply them together. And then you divide by the number opposite to X. Okay? The person who said I did not get it, and his name is M, so it's hard to call you. Do you get it now? The other thing is, it's a she, okay. The other thing is, your name is Miriam. Miriam, okay, Miriam. All right, so Miriam, did you understand this example? If you know that one friend eats 2 slices, then 25 friends are going to eat X, and X is these two numbers multiplied by each other divided by this number. You understand this example? Yeah. All right, what about Miriam? This example, 2 teaspoonfuls are needed for 1 cup. Then therefore, how many teaspoonfuls are needed for 35 cups? So what do? This is X, Miriam. You multiply these two numbers, and then you divide by the number that is opposite to X. Do you get this one, Miriam? So that's the second example. You did not get this one? So this X, what you do is you multiply these two numbers that are opposite to X. That are not on the, like, so this number opposite to X is going to be in the denominator. You understand? Okay, you get it now? Okay. You guys know what is a denominator and what's a numerator? I took this in grade 3. Okay, good. Okay. So Miriam, same thing here. Here's your unknown. The number opposite to X is going to be in the denominator, and the two other numbers are going to be in the numerator. All right. Now, here's the thing, Miriam, Khadija, Mark, everyone, make sure that these two things on top of each other have the same unit. So they're both in grams. So this is going to be in grams. This is in grams. This is in grams. And these two are in the same unit. Both of them are in ml. Okay? So yes, exactly, Miriam, you got it. If one unit is different than the other, you make sure they are the same unit. Okay? You guys ready for Kahoot? You guys ready for Kahoot? Okay, let's get started. Just want to make sure you guys all have my phone number. Okay, here's my phone number. You can scan this to reach me. Here is, these are my notes. I give it away for free. If you want my notes, just let me know. Someone said they don't get it. I don't remember his name. Was it Abdullah? Abdullah said he doesn't get it. Okay, Abdullah, I'm going to repeat it very quickly. I also have summarized everything in 12 pages. It is so good. Just text me to get it. And also to let you know, Judy, either text me or text Miss Saba or text Miss Dina to get the notes. Okay, Judy? Text me. You have my number. Okay, this is my number, Judy. Okay? And here's the next session. Here's the next session. Next Sunday, the following Sunday, and August 14 is going to be the first session of a new course. It is a new course, so make sure you are here. Okay, so Abdullah. Abdullah, you said, oh, Nidhi, thank you. Just the first session, Cameron. Not the whole thing. It's twice a week for 9 months, okay? All right, Abdullah, where are you? Abdullah, Just want to make sure you are here. Abdullah, did you understand that if you know that one friend eats 2 slices, then 25 friends are going to eat an unknown, an X, and you want to calculate the X? How do you calculate the X? The number that's opposite to X, that's facing the X, this number that is facing the X, this number goes to the denominator. Do you get it now, Abdullah? And the other 2 numbers, you multiply them together and they go to the numerator. Do you get this one? Okay. So Abdullah, that applies to everything. All cross multiplications work the same way. Okay. Thank you, Minatullah, for answering. All right, let's do the Kahoot, guys. Let's do the Kahoot. And so today is pressure and temperature. Here you go. Let's host this live game. Hands on the keyboard. Can I ask something first, please? Yes, of course, guys, you can still ask our amazing, lovely 2 assistants, Jana and Minna are here. And okay, here's your pin. You go to kahoot.it and you put this pin number. Maryam, you want to talk? Okay, here you go. Please talk. Let me raise the voice.
Okay, I don't know how to type this. That's what I wanted to ask.
Yeah, sure.
When you said cross multiplication, what I learned is like we can use the same example, but then it's gonna be like 300x equals this times this, and then we arrange the formula.
And then isolate x. Same. Yes. You can do 300x is equal to the opposite numbers. Yes.
Okay, thank you.
Yep. You are welcome. Cameron, I work at clickcourses.org. You can go to clickcourses.org. Okay. And someone else, RM, you need the notes in the brief. Just text me. You have my phone number, right? Ms. Dina, can you post my phone number, or Ms. Saba? Yeah, both of them are here. We have some amazing assistants today. They are amazing. Okay. Omar, you have your hand raised. Do you want to talk? Do you want to ask a question? Iyad, you also have... What?
I just have a question.
Yes. What's your question?
So like in the particles, like in the balloon one, in the particles, don't they get more energy if they collide more?
That's a really good question. Excellent. Oh my God, Omar, you're so smart. They do just a little bit, and we ignore this little bit of in physics. You take the friction can the friction energy can be converted into kinetic energy and stuff, and yes, the temperature can increase a little bit, but just a teeny bitty, very, very small, that we ignore this fact. Okay, Omar or Umair? Umair, is it Umair? How do you say your name?
Omar.
Omar. Okay, Omar, thank you so much. Excellent question, very smart. All right. Iyad. Noor is asking where I'm from. I live in the United States. I've been here, I don't know, 17 years, since 2007.
Hello, teacher.
Yes.
No, in the beginning I just wanted to answer, but then I couldn't, so I just...
Oh, it's okay. Iyad, you're doing wonderful. I saw your chat. Great answers. Amazing. So Noor, I was born and raised in Dubai, originally from Egypt, currently in the States. So 3 places actually now. Abdurrahman, do you have a question?
Yes, I took before in chemistry in school that if there's more mass, there will be more energy in total. Like if I have small glass of water, 20 Celsius, and a lake of water that's 20 Celsius, the lake has higher energy.
If there's more mass, it's gonna have higher energy?
Yeah.
No. Energy has to do with temperature. What the temperature is of your surrounding. It has to do with the heat you are providing. It's not about the mass. It is not about the mass. Okay, let's take 2 more questions and then we're gonna start the Kahoot. Not for a while, Judy. Oh, Noor, you are. Same story. Okay. Doha.
Hello, teacher.
Hello.
Teacher, I wanted to ask, like, the questions that you give, which you provide as 2 marks, 3 marks, what if it comes like more than 3? What can I write?
They're not gonna do that, Doha. They are not gonna do that because what are you gonna say? Like, right? I mean, there's limited stuff you can say. The examiners are not gonna be that bad. Cameron AQA, yes. So yeah, Doha, do not worry. They're not gonna be that bad, right? Jessica. Jessica, you're here? You have your hand raised? Okay, what about Khadija? You have your hand raised? You have a question? Yusuf?
Hi,
Yes, Khadija.
Assalamu alaikum.
Walaikum salam. How are you, Khadija?
I'm fine, thank you. Alhamdulillah. How are you?
I'm doing wonderful. The fact that you guys are here and you're excited for the Kahoot and you're ready is making me happy.
I have one question.
Yeah.
Do you use cross multiplication in physics or just in chemistry?
Cross multiplication is the same everywhere, right? And
Yeah,
sometimes they do like x times what's opposite to it divided by the other stuff. Same thing, you're gonna get the same answer.
it's just that in the UK, right? They use like a different system, so I'm kind of new to this process. So
To the cross multiplication
yeah,
should be the same thing, Khadija. Exactly the same thing.
I don't know. They just teach it a different way. In a
Text me with
different
the other different way. I'm happy to learn about the other way.
Teacher, can you start the game?
Yes, let's start the game. Is everyone ready?
Teacher, I have a question real quick.
Yeah, Jessica.
You're explaining the questions. I feel like it's more of the Excel, not Cambridge, right?
They all do the same thing.
Really?
Today's
'Cause, like, you're
session,
saying some keywords.
this short course is for all boards at Excel,
Yeah.
Cambridge, and AQA. And the reason is for these sessions, for these topics, they kind of teach it the same way, or actually Cambridge does ask about this. So
But
they
I
do.
meant like I feel like you're telling us to like learn the keywords, but I feel like in Cambridge, you just like you're explaining in your own way.
Yes, you can write your own way, or you can use the keywords. However, Jessica, there's a big problem when I leave the students to write whatever they want. And you know what that problem is? Sometimes they write wrong things. Like the examples I gave today, sometimes students will say, "Oh, they hit harder." The word harder, Cambridge will not accept it. It's wrong.
Right.
Because there's nothing about energy or temperature, right?
Yes.
So, as a teacher, I have to be careful with allowing students to just write whatever they want. They can, but if it's correct, yes, that's fine. But if they just write wrong stuff, they're gonna be in big trouble. So we want to make sure they write the right thing.
Right.
Yeah.
Okay. Thank you so much.
All right, you are welcome. Let's get started, guys. How many people are here? 88. Okay, let's get
Miss, I
started.
had a question.
Yeah.
Miss, could we say if the balloon has more pressure inside, that it will there is pressure inside more than the pressure outside, so it will burst?
Yes. The comparison of inside and outside is more physicsy, but that is the correct answer. All right, guys, let's get started. There's 90 people here. That's amazing. I don't know how there's 90 when there's only 89 participants, but anyhow. All right. 3, 2, 1. Everyone's ready. Hands on the keyboard. Why does decreasing volume increases pressure? Why does decreasing volume increases pressure? And I give you 45 seconds, but the next one is not going to be 45 seconds. Yes, Sarah, exactly. You got it right. Sarah typed the answer. Wonderful. 13 seconds. One more. 90 answered. Wonderful. 5 seconds. 3, 2, 1. Yes, particles get closer. Particles get closer. You cannot choose answer. Why, Sarah? Look at this chart. The code is at the bottom. Noah, the code is at the bottom. You see the bottom of the screen, 9036915. Okay, question is, increasing temperature increases gas pressure because increasing temperature, toddlers, sugar, increases pressure because, thank you, Minatullah. Amazing. Wonderful. 21 seconds. You pressed the wrong answer, Doha. Come on. Khadija, it's up to you. Do you want to go? I mean, it's fun, right? Okay, 6 seconds. Increasing temperature. And of course, increasing temperature, the particles gain kinetic energy. Wonderful job, everyone. All right, true or false? Pressure is directly proportional to temperature. Pressure is directly proportional to temperature. Look at you guys. 50 people answered in the first 5 seconds. So smart. Yes, Najah, that's right. Okay, Khadija, no problem. You're going to be here next Sunday, right? All right, that is true. They are directly proportional. Pressure is directly proportional to volume. Pressure is directly proportional to volume. True or false? True or false? Pressure and volume. Aha! Thank you, Omar. This is false because they are inversely proportional. All right. What is an example of increasing pressure by increasing temperature? An example of increasing pressure by increasing temperature. So, Cameron, this course, this short course, the 4 sessions, will apply for all the courses because it is the basics of chemistry, right? These are the basics of chemistry. It's science. How many questions? 12 total. This is question number 5. So this is 5 out of 12. All right. So the good example here is the pressure cooker, right? 75 got it right. Oh, Miriam, thank you. This is Miriam, right? Why do balloons burst with more air? When you add more air, why do balloons burst? I put so easy, Kahoot. I should make this harder, right? Okay. Abdullah, chemistry is number 1 for me. Number 2 is math. Number 3 is physics. So I also like pharmacy. I teach pharmacy. So keep it easy. Yassine. All right. Balloons burst with more air because there's more particles that cause collisions. No, Jessica, it's a mix. These questions is a mix between like real life and things I created and exam questions. What happens to gas particles as temperature increase? What happens to gas particles as temperature increase? Gas particles move faster, lose energy, move slower, decrease in volume. So next time is not going to be 45 seconds. I'm going to make it 20 seconds. You guys can handle 20 seconds, right? I'm pretty sure, yeah. Abdullah's like, oh no! All right, you guys did great. Look at you. All right, question 8 of 12. What explains high pressure in oxygen cylinders? In oxygen cylinders, what explains high pressure? Is it increased temperature? Is it decreased particle size? Is it low kinetic energy? Is it decreased volume and added gas? Oh, Noah, why? Go to kahoot.it and put this pin number. All right, 10 seconds, guys. 10 seconds. So in oxygen cylinders, it's squished volume, decreased volume. There will be lessons on separation ways because that's what I take in school right now. Yes, the fourth one. Not next Sunday, the following Sunday. Nadine. True or false? Decreasing volume decreases pressure. Decreasing volume decreases pressure. True or false? Oh, that was easy. Yeah, Yassine, thank you. Of course. All right, 5 seconds. Of course, it's false. Decreasing volume increases pressure. All right, wonderful. Another true or false. In cold weather, tire pressure decreases due to kinetic energy loss. Thank you, Minna. Kinetic energy loss. Is that true or false? Why, Yassine, did you say that? In cold weather, do particles lose energy? In cold weather, do particles lose energy and therefore collide less frequently and therefore pressure decrease? Right? It's true. Yeah, that makes sense. Okay. 2 more questions. Double points for this one. Which of the following is not a way to increase pressure? Which of the following is not a way to increase pressure? Increasing temperature, decreasing volume, adding more gas, removing gas particles. This is easy. Which of these will not increase pressure? Adding more gas increases pressure, Yassine. Yassine Mustafa. Right? Increasing temperature increases pressure. Decreasing volume increases pressure. Adding more gas increases pressure. Removing gas will decrease pressure, right? Oh, okay. 3 seconds, 2, 1. And yes, of course, it's removing will not increase the pressure. Last question. What happens to gas particles as temperature increase? Mariam, thank you. What happens to gas particles as temperature increase? They collide more frequently. They decrease in volume. They move slower. Thank you, Marwan. They lose energy. Yeah. You're increasing temperature. It's like feeding toddlers sugar. Thank you, Mariam Amr. 3, 2, 1. And yes, they do collide more frequently. Wonderful, guys. Look at you. Here's the number 3 winner. Marwan is number 3. Awesome. Minna is number 2. Great job. And number 1 is Muhammad Samir. Wonderful job. You're number 4. Guys, I am proud of all of you. All of you did great. Amazing job. There are 83 attendees today. They all did great. Thank you so much, all. If we have any last minute questions, please let me know. If you need these notes today that I had for you, please text me. You guys have my phone number, right? You guys all have my phone number, right? Okay, let me give you my phone number again. Here you go. This is my phone number. I don't know, Ali. Who is I am watching you? I don't know. Oh yeah, in the Kahoot, yeah, people name themselves some stuff. So, Mariam, you have a question?
Yeah, Miss, I think it's off topic, but I'm just curious. Like, when you said like the top of the pressure cooker gets hot, is it because like the thermal energy from the particles are transferred like to the top of the pressure cooker?
That's one thing, but I had another point, which is you don't want to take the lid off when you have high pressure, because then the gas will just leave very quickly.
Oh,
That was the point, yes.
oh,
So,
okay.
yep. All right.
Thank
Miriam,
you.
you have a question? Can you unmute, please?
Yes, Miss. Miss, is there any lessons after February, the next lesson, February, I think 23?
So we're gonna have two more. This one is going to be atomic structure and the history of the atom, and this one is gonna be about separation technique. And then no, I'm gonna focus with my students because they have exams. So I'm gonna be
Okay.
very focused with my current group of students who are taking the exam in 2025. So we're gonna get really busy. We're gonna have a lot of exams and stuff. And then the new course starts August 14. All right, so
Oh,
please.
okay, thank you.
Yep. All right. Anyone else who's questions? Any other last minute questions? All right. Thank you so much. Yes. Good job, everyone. I agree, Minna. Everyone did amazing job today. Thank you so much. Love you all. See you next Sunday. Make sure you're here. If you need anything, you have my phone number. Yes, I do check my WhatsApp maybe once a day or once every couple days. Miss, may I have your course for high level? A levels, yes, next year, Ida. If you want to join, please make sure you are in touch with me or with one of my assistants by mid-August. I start all courses mid-August. I start early. Yeah. All right. O level, same thing, mid-August. Everybody starts mid-August. You cannot scan the QR code. Please be put back on. What? Here's my phone number, Cameron. Can't he QR code, please? I don't understand the statement. Doha, yes. Next year, Doha. Oh, for the book. Here, just go to Amazon and search The Joy of Chemistry or search my name. You're gonna find it. What's gonna happen in August? I start new courses in August, mid-August. Yeah, just asking what happens in August. I start my courses. All right. Thank you so much. Thank you, Cameron. Thank you, Adam. Thank you, Abdurrahman. Thank you, Abdullah. Thank you, Skittles. Yeah, thank you. Thank you, Miriam. Thank you, Ahmed. Who else is here? Thank you, Najah. Thank you, Doha. Thank you, Dana. Gina, Iyad, Julia. We have a Julia here. My daughter's name is Julia. Thank you, Kareem, Huda, Lena, Mahmoud, Malak, Marwan. There's like 3 Mariams. Mazen, Minna, Mahmoud, Ola, Noor, Noah, Sarah, Salma, Rainbow, Shahira, Victoria, Yassine, and Yusuf and Yazan. Thank you so much all. Big thank you to my assistants, Miss Dina, Miss Saba, Miss Jenna, and Miss Mariam. They did amazing today. They were very helpful. They answered so many questions. I see more than 90 questions answered on the Q&A and a ton answered on the chat. That was wonderful. Thank you all so much. Many thanks, many love. See you all Sunday. Thank you all. Bye.